Let's take our next question, that is question number 13. Two electric bulbs are marked at 60 watt 220 volts and 100 watt 220 volts are connected in series to 440 volt of supply. Which of the bulbs is more likely to get fused? Definitely the bulb which is getting a voltage more than the rated voltage, more likely it will be fusing. So let's start the solution. I've already made a diagram for the simplified version. So what we have supplied is 440 volts. This bulb is rated as 220 volt, 60 watt, right? And this one has been rated as 220 volts, 100 watts. So what about the resistance of this one? It would be 220 whole square by 60, and the resistance of this would be 220 whole square by 100, right? Let's take this potential as V1 and this potential as V2. It's pretty easy. Now, if you just take the ratio of V1 and V2, since they are in series, they will be having same current. I can write V1 upon V2 would be equal to R1 by R2. And if you understand that the resistance holds a relation of V square by P, which I have written up there. So if you solve, you will get 100 by 60 or 5 by 3 for this. Now, if you have V1 by V2 is equals to 5 by 3, you can find that V2 will be equal to 165 volts and V1 would be equal to 275 volts. As you can see, the V2 value is 165 and this is 275. V1 is greater than the rated value of potential. So definitely first bulb of 60 watt power will fuse. Let's see which is the best suited option. Yes, answer to this question would be option 1. Now let's move on to the next question, that is question number 14. Now here in this question, the circuit, it's in steady state and we have to find the incorrect statement. So it's quite a complex problem, a lengthy one. Let's start the solution of the same. So we have been given some of the data points here. In order to simplify the solutions, I have already marked this diagram here. Let's start with the very first point, that potential at M is equal to 3.6 volt or not. We have to verify these. Let's take this potential as V. Now let's assume that I current is flowing down in this direction, I1 in this direction, and I'll take this portion. Since it's a 0 volt potential, it's been grounded, I will not assume that any current is going there. So 2 and 4, they will together be in series and they will be known as 6 ohm, and 6 ohm together with 3 will become what? 2 ohm. So down the line, this will become 2 ohm for me and this is 4 ohm. And let's imagine there's I2 current is flowing down, right? Now let's put down the values. So what I can write is I would be equal to 6 minus V upon 2, right? Similarly, I1 can be written as V minus 3 upon 1 and I2 can be written as V minus 0 upon 6, as 2 and 4 are in series. This I am taking as 0 volt. Now with Kirchhoff's first law, I is equals to I1 plus I2. Let's put down the values as 6 minus V upon 2 is equals to V minus 3 plus V by 6. Simplifying this, what we get is V equals to 3.6 volts, right? So let's see about the first statement, that potential at M we are getting as 3.6. Yes, this is correct. Okay, but we have to find the incorrect one. Now let's come down to the second statement. If this is 3.6, you can easily find that I2 would be equal to V by 6, that is equals to 3.6 by 6, that is equals to 0.6 ampere, right? Now imagine if 0.6 ampere is coming down the lane here, so the potential drop across this would be 2.4 volts. That means potential at N point should be 2.4 volt, then only the potential drop of 2.4 can come here. That means this statement of potential at N is 2.4, that's also correct. Now, if you concentrate, this potential is 3.6 volts, this potential is 2.4 volts. So for capacitor of 2 microfarad, the potential difference which is available is only 1.2 volts. Due to this, the capacitance into potential, that is 2.4 microcoulomb of charge is possible. That means this statement is also correct. So among the 4, 3 are correct. The last one which is pending, this one is the incorrect statement. So answer to this question would be option number 4. Now let's move on to our next question. That is question number 15. Here there are two spherical regions having uniform volume, charge density rho and minus rho. Both the spheres have equal radius r and separation between the centers is d. The spheres are laid down such that they overlap as shown in the figure. The electric field in the overlapping region is, right? So for the spheres which is having the uniform charge density of rho, electric field can be given by formula rho r vector divided by 3 epsilon naught, right? Now in the region where overlapping is happening, the net electric field would be said to be E1 plus E2. Now let's write the expressions for E1. That is equals to rho R1 upon 3 epsilon naught, and E2 will be written as minus of rho R2 vector divided by 3 epsilon naught, right? Now as per the equation 1, let's just add down the values. So when we add them, you will find that E net is equals to rho upon 3 epsilon naught R1 vector minus R2 vector, right? And it's given in the question that R1 minus R2 is equals to di cap. So the net vectorial expression, this should be in vectorial form, it becomes rho di cap upon 3 epsilon naught. Let's see which is the best suited option as per the given condition. So here option number 3 is the correct answer to the question. Now let's move on to our next question, that is question number 16.